Welcome to Physics Chapter 4, Lecture Number 2. We are going to cover on your own problems 4.5 through 4.7. On this video, we are basically, this starts at page 115, this lecture. And it's about the range equation. So this is a special situation with parabolic motion. So the range equation, the equation you're about to learn, can only be used in parabolic motion. And the landing height has to equal the launch height. All right, so it's only where landing height is equal to the launch height. In the next lecture, we're going to do problems where that's not true. So in the space in your notes, write down this equation. The range equation, and what the range means, what you're finding is delta x sub x. That's what we call the range. Okay, it's equal to the initial velocity squared times the sine of twice the angle. So we call that 2 theta, twice the angle, over g. Now, what is g? G is just the positive acceleration due to gravity. So instead of negative 9.8 or negative 32, we're just going to make it positive. All right, that's all you got to know. You just got to memorize that, and let's work some problems. So our first one is 4.5, and that is going to be on page 120. Right, so that one says a cannon is tilted at an angle of 42 degrees relative to the ground. If the cannon launches its projectile with an initial speed of 150 meters a second, what is the range of the cannonball on level ground? Okay, that intimates level ground, that it's going to land at the height it was launched. Okay, so the range, delta x, the displacement in the x direction, is equal to, all right, the initial velocity. We don't have to do anything involved with trig here, that 42 degrees. It's just 150 meters per second. We have to square that. Multiply that by the sine of twice the angle. Well, the angle's 42 degrees, so twice that would be 84 degrees. All right, we're in meters, so it's going to be divided by 9.8 meters per second squared. All right, if we put that in our calculator and we don't mess that up, let's go ahead and just show you how I would put that in. Okay, so it's going to be 150, and then I hit the x squared button, times the sine of 84. I'm going to go ahead and close the parenthesis, divided by, and I'm going to go ahead, I don't know if I need to do this or not. Let me go ahead and do it this way. Divided by 9.8. Right, that gives 2,283.3 meters, and that is correct. So that's how far in the x direction that goes. It doesn't tell you how high it goes, just how far in length that it goes. All right, let's try 4.6, which is right underneath. That one says a missile is aimed at an angle of 23 degrees relative to the ground. If the missile's target is 5.4 times 10 to the fourth, that'd be 54,000 meters away and in the same elevation, at what speed must the missile launch in order to hit it? So this time, we have the range equation, and we need to rewrite it and solve for velocity. So I have delta x sub x is equal to v naught squared times the sine of 2 theta over g. Now I got to solve for v naught. So let's multiply both sides by g and then divide both sides by sine 2 theta. So if you do that, v naught, you can try this on your own, and because it's squared, it'll be the square root of all this, delta x sub x times g over the sine of 2 theta. All right, so we multiply both sides by g and then divide both sides by sine of 2 theta to solve. So if you want, just circle that. That's what you're solving for. And then we have to take the square root of that whole thing. So now it's just a matter of plugging in numbers. Okay, we want the range to be 54,000 meters. You can do it in scientific notation if you want. Gravity would be 9.8. Our angle is 23 degrees, so twice that would be 46 degrees. So sine of 46 degrees. All right, so how would I put this in my calculator? Well, this is the way I would probably do it. I'm going to put, let's see, I'm going to say 54,000 times 9.8 and hit enter. And then I divide that answer by the sine of 46. Hit enter. That's that 735,000 number. And then raise that to the 0.5 power. You have 857.7. And that'd be meters per second. And that is the correct answer. So I feel like that's a pretty safe way to put that in your calculator. Just do it in 3 different steps in your calculator. Because these calculators are great at remembering where you are. Okay, 4.7, and this is a nice short lecture. This is the last one of this lecture. So we have a rifle shoots its bullet at an initial speed of 200 feet per second. At what angle should a marksman aim his rifle to hit a target that's 500 feet away and at the same height as the rifle? So again, I like to solve these in variable forms first, and then just plug the numbers in instead of putting the numbers in first. Okay, so we have this equation, this delta x sub x is equal to v naught squared times the sine of 2 theta over g. This time we want to solve for the angle. So I'm going to solve for sine of 2 theta and then work from there. So let's multiply both sides by g and then divide both sides by v naught squared. So sine 2 theta is equal to delta x sub x, that's the range, times g, divided by the square of the initial velocity. So sine 2 theta is equal to, let's see, 500. And be careful here, it's 32, since we're in feet. Easy to put 9.8. Lots of students have done it. And then our initial velocity is 200. Don't forget to square that. All right, so putting this in your calculator, we've got 500 times 32. And then divide that by 200 squared. And it is 0.4. Now that's not the angle, is it? That's the sine of 2 theta is equal to 0.4. So 2 theta is equal to the inverse sine, in order to get the angle, of 0.4. So the inverse sine of 0.4, so we'd hit the blue button and sine 0.4, is 23.6 degrees. But that's twice the angle. So theta we would divide by 2. Which is 11.8 degrees. All right, pretty cool. Not very hard, but you do have to memorize the equation and then be able to do the algebra. All right, so our homework is pretty short for this section. So I'm just going to stuff it right over here in this corner. It's review question, page 138. You can do number 7. And then practice problem, page 139. There's 3 of them that you can do, 5 through 7. All right, so that'll be homework number 2. All right, great. I will talk to you next video.